Hello, let us write a C program to generate the result of following series: 1 upon 2 factorial plus 1 upon 4 factorial plus 1 upon 6 factorial plus 1 upon 8 factorial dot dot up to 1 upon n factorial, right? We want to generate the result of this series. That program should work and give you the final number. What are the inputs to this program? Inputs is, I can see that there is one input, right? That is the value of n. The value of n is needed because this is an infinite series, right? And because this is an infinite series, the program should stop calculations at some point, and hence we are taking n as a user input, right? Okay, now we have thought of user inputs. Now we want to think of what are the tasks that this program should do. Okay, now when you're thinking of tasks, think of tasks with a free mind. Don't think of like sequence of tasks. I'm not talking about that. I'm just talking about like what all things you'll have to do in this program. One thing that I have to do in this program is calculating factorial, right? I have to calculate factorial, right? Why? Look at this: 2 factorial, 4 factorial, 6 factorial, 8 factorial. For any n I have to calculate its n factorial, right? That's one thing that I have to do. What's the next thing that I'll have to do? The next thing that I have to do is sum. Look at this: plus 2 factorial plus 1 upon 4 factorial plus 1 upon 6 factorial plus. So this program has to do addition, right? What's the next thing that this program has to do? The next thing that this program has to do is sequence generator. What's sequence generator? Oh, look at this: 2, 4, 6, 8. What is this? 2, 4, 6, 8. What's the next number? 10, 12. Yeah, you're generating even numbers. So generating even numbers is also one of the tasks of this program. Okay, cool. So now we have identified what input we will take, that's value of n, and we have identified 3 different tasks that we have to do. Now let's think of solving this by understanding each of this task and translating that into a program, right? Okay, let's take the task of factorial. Okay, for factorial, all you need is a variable f with a initial value as 1, and then you need this loop. What's the loop? Yeah, this loop. While x is greater than 0, f is equal to f multiplied by x, x minus minus. That's it. This loop will give you what? This loop will give you factorial of x. You give it any x, it will give you factorial of x. Let me correct myself, right? It's not the loop, it's this program. So this program will, so to this program you give any x, it will give you factorial of x. That's all. The important thing to remember is initial value of f has to be 1. Let's prove that point, right? Let's prove that point. Let's prove it by taking an example, right? What's the example? Let's take value of x as 4. So when value of x is 4, we expect 24 to be the output because that's the factorial of x, right? What's the initial value of f? We said that the initial value of f is 1, right? Okay, now be with me. While x greater than 0, look at this condition: x greater than 0. What's the value of x? 4. Is 4 greater than 0? Yes. And because 4 is greater than 0, I will go inside the loop. When I go inside the loop, I have this statement: f equal to f multiplied by x. Look at only this part of the statement: f multiplied by x. F multiplied by x. 4 multiplied by 1. What is that? 4. Right? That's 4. And where I'm storing that 4? in f. Here you go. So you are overwriting f itself with this result. So f gets 4. What's the next statement? Next statement is x minus minus. X minus minus. What's the previous value of x? 4. What's the new value of x? 3. What's the next statement? Next statement is this curly bracket. And because of this curly bracket, machine goes back up and checks the condition. What's the condition? X greater than 0. What's the value of x, right? Look at this. The value of x is 3. Is 3 greater than 0? Yes, it goes inside. Does f is equal to f multiplied by x? So look at f multiplied by x. What is f multiplied by x? 4 multiplied by 3, right? What is that? 12. Where will that 12 go, right? That 12 will go back in f only. So f gets 12. What's the next statement, right? X minus minus. The previous value of x is 3. The new value of x is 2. After x is 2, you see this magical bracket. And because of this magical bracket, you go back up and check the condition. What's the condition? X greater than 0. What's the value of x? What's the value of x? 2. Is 2 greater than 0? Of course. So it goes inside and again does f equal to f multiplied by x. So multiplication of this 2 stored the result here. 12 multiplied by 2, where to store the result? 12 multiplied by 2 stored the result in f. So f gets a new value, that's 24. After f gets 24, x minus minus. What's the previous value of x? 2. What's the new value of x then? X minus minus. X becomes 1. After x is 1, this x minus minus is done, then this magical bracket. Because of this magical bracket, control goes back up and checks the condition. Is 1 greater than 0? Oh yes, 1 is also greater than 0. So it again goes inside and does f multiplied by x. What is f? 24. What is x? 1. F multiplied by x. 24 multiplied by 1. What's 24 multiplied by 1? 24. Where it will store that 24 multiplied by 1? Back in f. It's important that 24 gets overwritten with 24. The value is same, but there is still a memory write operation. Okay, yeah, you could have avoided this multiplication by saying x greater than 1, right? You are going up to 0 and unnecessary multiplying till 1, but that's just fine. That's an optimization, right? I wanted to put an emphasis on a point that 24 gets overwritten with 24. System does not know that they are same values, right? It just overwrites. Okay, after that x minus minus, right? Previous value of x is 1, new value of x is 0. What is this? End of while, that magical bracket. And because of that magical bracket, control goes back up and checks the condition. What's the condition? X greater than 0. What's the value of x? Look, the value of x is 0. Is 0 greater than 0? No, 0 is not greater than 0. 0 is rather equal to 0. So it comes out. So it comes out of the loop, right here. When it comes out of the loop, look what has happened. Interesting things have happened. What's the value of f? Value of f is 24. So you got 24, right? What's the value of x? Don't forget, that's also important. What's the value of x? Oh, initially the value of x was 4, but now the value of x is 0. So this loop actually did two things. It made x as 0 and it gave you factorial of x as 24 in variable f. What did it need? You had an initial value of f as 1. That initial value of f has to be 1 for this thing to work, right, before the loop. Alright, let's summarize. Summary: initial value of f must be 1. After the loop completes, x becomes 0 because x is the number whose factorial you want to calculate. That becomes 0, it vanishes x. That's a side effect, right? But then f will contain factorial of x. So this while loop does that. Now let's talk about the next task. What was our next task? Yeah, we can pick up anyone. Let's pick up sequence generating, right? Let's pick up the sequence generating one, this one. sequence generator, right? So let's pick up the sequence generator, right? Sequence generator. How will you generate the sequence, and what sequence you have to generate? Look at your problem statement, right? Where is the problem statement? Yeah, your problem statement is 2, 4, 6, 8, 10, like all even numbers, right? So go back. Sequence generator. I want to generate all even numbers. I can use a simple for loop, right? K is equal to 2. When k is 2, I can go inside, calculate factorial of 2. Okay, this is that factorial thing. Calculate factorial of 2, generate the next sequence. What's the next sequence? 4. K is equal to k plus 2. Then k becomes 4 because previous was 2. Now k is 4. Again go calculate factorial of 4. K equal to k plus 2. Then k becomes 6 because previous k was 4. Calculate factorial of 6. K equal to k plus 2. K becomes 8. Keep on doing this till the time k does not cross n, which is your user input. So this is your simple for loop that can generate a sequence, right? Very simple, right? Yeah, we have like seen for loops so long, like it's this step is really very simple. Okay, so all we are doing is saying start with 2, each time increase k by 2, and keep on doing this till the time you don't cross n, and then for each k calculate the factorial of k. Okay, so that's how you will code the sequence generator task. Yeah, you could also write k plus equal to 2, which is like a shortcut or a shorthand notation to a long statement k equal to k plus 2. Okay, anyway, let's go to the next task, right? Calculating sum. How will you calculate sum, right? Let's try to calculate sum of all the even numbers. What are the even numbers? Let's start from 2 because that's relevant to our problem statement. 2, 4, 6, 8, 10, right? These are your even numbers. Yeah, it will become difficult for me to like explain assuming a long series. Let's assume a shorter series. Let's assume only 2, 4, 6. Let's calculate like a sum of only these three numbers, 2, 4 and 6, right? How will I do that, right? So I have a for loop for k is equal to 2, k less than or equal to 6, k plus plus, no k plus plus. Why no k plus plus? Because now you need k is equal to k plus 2, right? In each time increment. So 2, then 4, then 6, right? Yeah. What I need to do is I need to take that k. So initial value of k is 2. So I need to take that 2 and add it with the previous sum. When 2 comes, what's the previous sum? Well, the previous sum is not there, so 0. So 0 plus 2, because k is 2, and I'll store that in new sum. So s is equal to s plus k, right? What's your initial sum, right? That's very important, right? What's your initial sum? 0. So initial value of s has to be 0. When initial value of s is 0, this particular block will like give you sum of all k's. Sum of all k's. Yeah, k, sum of all k. Okay, let's try to prove that point, right? Let's try to prove it. So when k is 2, right? Let's say k is 2, right? Initial value of k is 2. Is k less than or equal to 6? Yes, k is less than or equal to 6. 2 is less than or equal to 6. It goes inside and executes this. S is equal to s plus k. So only look at s plus k, right? What is the value of s? 0. Initial value of s is 0. And then the value of k is 2. 0 plus 2. What is 0 plus 2? 2. Where it will store that 2? In s. So s gets a new value, that's 2. Alright, that's done. What's this? This is what? End of for. And because this is end of for, machine will go back up and do k equal to k plus 2. What's the previous value of k? 2. What's the new value of k? K equal to k plus 2. So new value of k is 4. After k is 4, it will go and check the condition. Is 4 less than or equal to 6? Yes, it is still less than or equal to 6. So it goes inside again and executes s is equal to s plus k. So let's execute s plus k. What's the value of s? 2. Look at this in the memory. What's the value of k? 4. So k is 4. What is 2 plus 4? 6. Where it will store that? In s. So s gets a new value, that's 6. After s gets a new value, that's 6. Look at this magical bracket. Because of this magical bracket, it does k equal to k plus 2 again, goes back up, right? That's why you call it as magical bracket, right? K equal to k plus 2, so k becomes 6, right? After k becomes 6, it again checks the condition, k less than or equal to 6. What's the value of k, right? The value of k is, right, 6, right? Is 6 less than or equal to 6? Yeah, 6 is also equal to 6, so it goes inside again. And when it goes inside again, it again executes this s is equal to s plus k, right? What's the value of s? Value of s is 6. What's the value of k? Oh, value of k is also 6. What's 6 plus 6? 12. Where it will store this 12? It will store it in s. So s gets a new value, that's 12. After s gets a new value, that's 12, this curly bracket, because of this curly bracket, k becomes k plus 2. Because k becomes k plus 2, k becomes 8. After k becomes 8, it again checks, is 8 greater than or equal to 6? Oh, 8 is not greater than or equal to 6. The condition is false. Because condition is false, it comes out. When it comes out, what is the result? Look at the result. Variable s, yeah, let me use a different color. Variable s contains a value 12, and that 12 is nothing but sum of everybody. Sum of all these three numbers is like 12. Okay, so this is how you can calculate sum. Right, let's write the program now, right? Let's write the program, right? Yeah, here is the program. This program is the program to generate the like series. Now what I've done is I've just integrated all the small concepts together and formed a program. Let's go it one by one, right? So hash include stdio.h void main, all this is like standard C programming thing. I don't have to explain that to you. Look at these two lines. This is taking n as input from the user, because that's the first input that we described here, right? Look at this, inputs n. So we are go here. We are here. We are inputting n. That's the red highlighted. Let's go to yellow highlighted, right? The yellow highlighted is the sequence, right? Look at that. Sequence. Let's look at the blue highlighted, right? The blue highlighted is sum calculation. Sum. Right? Yeah, it's just that instead of I'm not calculating the sum of f's, but I'm calculating sum of 1 by f's, because I want to do 1 upon 2 factorial plus 1 upon 4 factorial plus 1 upon 8 factorial. And we very well know, as per green highlighted, that this while loop calculates factorial of x. So this calculates factorial, f contains the factorial, and I am doing the sum, right? Take a moment to look at this program and relate it with the concepts. I'm sure you will like very nicely understand that. Okay, what is important to calculate factorial is f has to have an initial value of 1. The green calculates factorial, the blue is the sum logic, the yellow is the sequence logic. There is one more very important thing that I didn't explain, right? Okay, so let me try to explain that. So that one is this orange highlighted, right? X is equal to k. What's x is equal to k? So what are we doing actually? Let's have a thought over this x is equal to k for a moment, right? What are we doing? So you have a k, right? You have a k is equal to 2, so you have a k. You put that k in x here, right? As per this statement, what are you doing is you're putting that k that you have into x, and then what are you doing? Then that while loop runs, that calculates factorial of x. When it calculates factorial of x, what is the result? Yeah, this factorial of x, what is the result? Two results. F contains factorial of x, so f contains factorial of x, and x contains 0. Recall, I had already mentioned, right? X contains 0. Okay, but yeah, and then you're summing it. That's fine. Why are we doing like this, right? Why are, like, my point here is only explaining this. Why are you putting k in x and then calculating factorial of x, right? If you don't do that, what will you do? You will say k is here, I don't need x, and I want to calculate factorial of, you don't have x, so you'll calculate factorial of k directly. So because you are not creating x, then, right? Then what will be the result? Two results. F will contain factorial of k. So f will contain k factorial, that's just fine. But what's the second result? Oh, k will become 0. Just like your x becomes 0, your k becomes 0. And that's a problem. So if k becomes 0 here, k plus 2 will be 0 plus 2, that's 2 again. So let's start. K is equal to 2, k becomes 0, and then k plus 2. So again 0 plus 2, that's 2. That's not correct. You don't have to do this, that's why. Because you don't want to make k as 0. K should continue the sequence while this green loop is calculating the factorial. 2, 4, 6, 8. So that's why what are you doing? K is 2. So x becomes 2. X becomes 0. But k is still 2. X is 0. That's fine. And f contains factorial of 2. That's fine. But next time when you do k equal to k plus 2, you get k as 4. Then k as 6. Then k as 8. If you make k 0 internally, then you will never be able to progress gracefully in the series. That's the significance of taking the, like, taking or copying value of k in x. Okay? Right. Okay, few more important things, right, that I wanted to explain, right? So let's use the pink color, right? I have created this double variable, right? S is double, and I have created f also as double, right? What's the reason of that, right? What's the reason of creating a double variable? Is because, let's look at why f is double, right? So f is double. When f is double, 1 by f, right? What is 1? 1 is int. And what is this? Double. So int divided by double becomes a double. So you get a fraction, right? Because int divided by double is a double, you get a double. But if you say int divided by int, you will never get a fraction, right? So let me try to explain that, right? Let me try to explain that. So if you have 3 divided by, or 30 divided by 6, right? That's int divided by int. When you say int divided by int, you will always get an integer, right? For example, that's fine because that's an absolute integer, right? But 5 divided by 2, when you do 5 divided by 2, you will get 2 because int divided by int is always an int. But if you say 5.0 divided by 2, right? What's 5.0 divided by 2? 5.0, right? Now this becomes a double and this is an int. So double divided by int, what's that? 2.5. So double divided by int is a double. So if you need absolute fraction, you need one of the quantities as double, right? So that's why I have intentionally made f as double, and the advantage of that f as double as, so one of the quantities is double, 1 divided by f. So that f is double, that's why you get a double, right? Yeah, and for similar reasons, s is double, right? Okay, so now that also explains why you have double. So that's it, the program will work. At the end, what are you doing is you are just printing the result, right? At the end, you are just printing the result of the full series. Okay, here you go. What book to refer, right? You have to refer a book called as Computer Programming with C++. This one is that, and this book has a lot of solved examples, right? You have to refer a lot of solved examples that are available in this book, right? Here's the cover of that book, right? Chapters 1 to 10 explain C programming, and 10 onwards explains C++ programming, right? Please get this book, refer it. It is great use for this subject along with this course, right? Look at the cover carefully, right? You can pause the video and look at the cover, or pause the video and look at the Amazon link. The book is available on Amazon, and here is the Amazon link, right? Okay, thank you so much for your time. Nice talking to you. See you in the next video. Cheers.